Hello, we're back here again. Now we're gonna go over RS latches and D latches because they are what makes the memory be able to store information. First, we're gonna need an LED so we know when the memory is on or off. We're having to check for the state if it's true or false. The memory is gonna use two NAND gates. And they're gonna be connected like this. And then this is the one that's gonna give me the output. Then we're gonna need two switches. Let's leave them here. So you see, let me just put it here. This is called RS latches because R for reset and S for set. Set means making it 1 and reset means making it 0 or clear, or could also be with RS latches for reset and set. If you see, when this one is 1 and this one is 0, it sets the memory to 1. And when this one is 1 and this one is 0, it sets the memory to 0. But when both are 1, it maintains the state. The two most important aspects of any memory is being able to change the information from 1 to 0 as you please, and being able to maintain it. Since you can do both things with this one, you can actually use reset it to 0. Well, right now it's 0, but as you see with two ones here, it maintains 0, or let's say I put it to 1, and with two ones it maintains 1. I'm gonna explain first the RS latch, then the D latch, and then I might go over why this works, but I'm not gonna go into that specific right now. But that's it. You have two NAND gates, you have two switches or whatever input they have here. They're gonna be connected to this side. If you make the left one, the one that is not connected to the output 0, and you leave this one to 1, you're gonna reset it. If you put the reset to 0 and then you leave the set to 1, you're gonna set it to 1. And what you have both in 1 is gonna maintain whatever you have here on the output. And the issue with this is that when you put both zeros here, the NAND gates are gonna cycle back and forth. Actually, they're gonna set both to 1, and then when you put this one to 1, these ones are gonna cycle back and forth between 1 and 0. And you have really no way to predict what's gonna happen. In Creativerse, since probably one is done before the other one, you're not gonna have the cycling back and forth. You're just gonna have the first one, I believe, is gonna set to true, and then the other one that is calculated is gonna set to false or something like that. But in electronics, it's not very reliable. On Creativerse, probably depends on the one that's calculated first that you use. I believe it's calculated by placing order. So the point is that it's not really reliable. When you put two zeros here, it's not gonna work. So you want to have 1 all the time, and then you put to 0 the set if you want to reset it, and so you leave the the reset on 1, or you put the reset to 0 and leave the set to 1 if you want to keep it. But since putting two zeros corrupts the memory, smart people found a better way to do it, and it's with the D latch. Let's just do it like this. The D latch is gonna use the latch is gonna use 4 NAND gates. Skip that. And then this one's going to be connected to this one. And the important part to notice is that this part right here is a RS latch. So it's just an R// with 2 extra NAND gates. And then this one's gonna connect to here, this one here. Now the funny part right now. This is gonna be the write enable, and this is gonna be the data. And we're gonna need an inverter. To this side, you're gonna connect not the data, and to this side, you're gonna be connecting directly to the data. And the write enable just connected to both the middle, right here. Of course, you don't necessarily need to connect it to the middle or to the other side, but this is how I would have seen it, and this is how I build it, because it really doesn't matter how you connect it on which side, but what matters is that you do it consistently, because otherwise you're gonna get mad when building like a bunch of those. You need to build it in a consistent manner. So here's what happens. When you have 0 here, it doesn't matter what you put here on the data. This is gonna be the data, and this is gonna be the write enable. When you put, let me just put it here for now. Okay, and let me just put it. So this is data and this is write enable. When you have data set to 0 or false, this is not going to affect the system. So you cannot write. So the write is disabled. But when you have the write enable activated, whatever you have on this side is going to be set into the output. So you can have 0 or 1. But at the moment that you put disable, whatever the write enable disable, whatever you have there is going to stay fixed, and doesn't matter how you touch this, it's not going to be active. That's really cool. And you don't have the issue with this one that you can have both to false. Actually, after I explain all the latches, I'm going to come back and explain why it works. But probably might not be that important to many people, so just stay if you want to hear it. Now I'm going to show you something even cooler that we can do with this. Let's say I'm going to build a new one. All these are NAND latches. NAND gates. And let's connect it. This to the side, this to the side, this one to the side. Okay, now we're gonna need a new data. Of course, a new inverter. Let's put it like this. This one sends to this side, this one sends to this side, and I will put the write enable. This is going to be connected to the write enable. Same with this one. And now it comes the interesting part. Both the latches are going to be using the same write enable. Of course, they use different data, but they use the same write enable. Meaning that if the write enable is disabled, or the write enable is not active, you can activate any of this and nothing's going to be written. But if you activate the write enable, you see this is false, so it says to false, and this one is false, so it says to false. So you really can mess with both of them. So when you do something like this and you activate use one write enable for both, these two works as one entity. So right now you have like 2 bits of memory working together. So it will be like in a space in memory. In the 8-bit machine, you actually have 8 of these ones because it's 1 byte working together. So you have 8 of these D latches connected to one write enable. And of course, you're gonna have to have 8 different data coming into the D latches. And the funny part is that you really don't need to use one switch directly to activate this one. Any true signal that you put to this one is gonna be active. Suppose that you have many slots of memory. One really cool way to make it work and just have one active at any time is using a decoder, as I show you. So how you are activating the memory is actually like that. You have a decoder and you activate the memory that you want through the decoder, and then you put in the data whatever you want, and it reflects on the memory. So yeah, that's how it works. Yes, that's all for this one. I'm gonna go over why this works right now. If you're interested, just stay tuned. This is the RS latch. This is gonna be like the complicated part, and then when we go to the D latch, we're just gonna cover this area here because this is an RS latch. So okay, these are NAND gates, meaning that they are false when you have true on both sides, and they are true when in any other situation. Remember that an AND gate is true when you have two truths and it's false on the rest. And this is a NAND gate, which is the opposite. It's going to be false when both are true and true in any other situation. Okay, so imagine that they're always going to be complementary. So you're always going to have true on one side and false on the other side, or true on this side and false on the other side. Let's start from this situation when it has to maintain the state. Let's suppose that you have true like in this situation and false on this side. If you put true here, you're gonna have true coming here and true coming here, so you're gonna have a false here. And then you're gonna have a true coming here and a false coming here, so this is gonna be true. So when on the next state, because this is gonna cycle, this one is gonna send true to here, so this is gonna stay false, so it doesn't change. And this one is gonna send false to here, so this maintains true, so it's not going to change. The same will happen if it's the other way around. If this one right here is true and this one is false, actually let me just make it like that. You see, this one is true and this one is false. When you have both truths right here, this one right here, since it has this one right here is going to have this true and this true, so it's going to be false, and it's going to be sending the false right here, and false with true is going to be sending true with the NAND gate. And of course true and true sends false, so it maintains the same state. Now let's suppose we make 0 this one. So if we make 0 this one, regardless of what you have here, this is going to be true, because anything with a false, you make this one false, anything with a false is a true. NAND gate is just false when both are true. So if you have a false right here, this is going to be true. So this is going to be sending true here, and since you have a true signal here, you are just putting 1 to false. This is going to be true, which is going to be false. This is how it is right now, so let's do the other way around. Let's say you put false here and you set this one to true. This should set it to 0, right? So if you put the false right here, no, set this to 1. If you put a false right here, false with whatever you have in a NAND gate is going to be true, so this is going to be true. And then it's going to be sending true right here, and true in a NAND gate is false, so it'll be sending false and true, which is true on a NAND gate. That's it, and that's it. It says it's true. This is a lot better just to see it like in a paper, and you make the different inputs that you can have and the time that it has at that moment, and after you let it continue through recycling, you can see the outputs that it had. But this is really cool because since it fits back into the other one, that's how you make it maintain the state. And then let's go to the D Latch. D Latch, this part is the same, so you already know that if you put a 0 to here and a 1 here, this is gonna be true. This is gonna be true right here. And if you put a 0 right here and a 1 right here, this is gonna be set to false. Let's start with the write enable. These are NAND gates, so you know that if any of this is false, the output of this gate is gonna be true. So when you put the right enable false, the output of these two gates is gonna be true, regardless of what you have in this one. If you have at least one false, the output is always true, because this is just true when both. This is just false when both inputs are true. So if you have at least one false, you are guaranteed that it will be true. So if you have the right enable connected to both, and you put the right enable to false, both of these are gonna be true. And you know that if you have two truths right here, it's gonna maintain the output regardless of anything. So you know that as you maintain the right enable to false, this is gonna be true, and this one is gonna be true. So it's gonna maintain the output. Now let's suppose you put this one to true. So you have, let's try to do it. I know what's true. Suppose you maintain this one to true. Now on this side is gonna be not the data, and on this side is gonna be not the data. The data directly. If it's true, you're gonna be sending 0 here and 1 here. If you have 1 and 1 on a NAND gate, it's gonna be 0. So if you have 1 and 0 on a NAND gate, this is gonna be false. So you have true on the right side and 0 on the left side. If you put a 0 on the right side and 1 on the left side, because true and true is false. So if you have a 0 on the right and a 1 on the left, you're gonna be setting it. Now let's suppose you make it 0. Now you're gonna have 0 and 1 here, false and true, and a false and a true in a NAND gate is gonna be true. Since this is false, this is gonna be sending true here, and you have true and a true, which is gonna be sending a false. So you have false coming here and true coming here. If you have a false coming here and a true in this direction, you're gonna be resetting it, which is make it 0. You see, this makes it true, this makes it false. And since you have just one wire enable, having that wire enable active will allow you to modify the two of them. And you're never gonna have the issue of having two false to both sides, because this one is always gonna be sending either one. Actually, what makes it is this wire enable connecting to both sides, because if you have this one to false, it doesn't really matter where you put this one. Remember the situation when you have two false coming here, and if you have this one to false, even if you put this one, the data to false, nothing's gonna happen, because both are gonna stay true as long as this one is false. Full pixie. And yes, that's about it. Thanks a lot for watching. We're gonna now move to the application of the D-Latches inside the 8-bit machine, which is, we have like a bunch of D-Latches in there. So I'm gonna show them to you. Thanks for watching.